So what I have here are 12 pieces of candy, and the ones that are colored in brown are made out of have chocolate on the outside, and the ones that have a C on them means that they have coconut on the inside. So for example, this one over here in the top left, it's made out of chocolate on the outside, but it doesn't have coconut on the inside. While this one right over here is chocolate on the outside and it has coconut on the inside. While this one, whoops, I didn't want to do that. While this one right over here does not have chocolate on the outside, but it does have coconut on the inside. And this one right over here has neither chocolate nor coconut. And what I want to think about is ways to represent this information that we are looking at. And one way to do it is using a Venn diagram. So let me draw a Venn diagram. So Venn diagram is one way to represent it. And the way it's typically done, the convention is that you would make a rectangle to represent the universe that you care about. In this case, it would be all the chocolate. So all the numbers inside of this should add up to the number of chocolates I have. So it should add up to 12. So that's our universe right over here. And then I'll draw circles to represent the sets that I care about. So say for this one, I care about the set of the things that have chocolate. So I'll draw that with a circle. It's not, oftentimes you could draw them to scale, but I'm not going to draw them to scale. So that is my chocolate set. Chocolate. That is my chocolate set. And then I'll have a coconut set. So coconut. Once again, not drawn to scale. I drew them roughly the same size, but there's actually, you can see the chocolate set is bigger than the coconut set in reality. Coconut set. And now we can fill in the different sections. So how many of these things have chocolate but no coconut? Let's see, we have 1, 2, 3, 4, 5, 6 have chocolate but no coconut. So that's going to be, actually let me do that in a different color because I think the colors are important. So let me do it in green. So 1, 2, 3, 4, 5, and 6. So this section right over here is 6. And once again, I'm not talking about the whole brown thing. I'm talking about just this area that I've shaded in green. Now, how many have chocolate and coconut? Chocolate and coconut. Well, that's going to be 1, 2, 3. So 3 of them have chocolate and coconut. And notice that's this section here that's in the overlap between. 3 of them go into both sets, both categories. These 3 have coconut and they have chocolate. How many total have chocolate? Well, 6 plus 3, 9. How many total have coconut? Well, we're going to have to figure that out in a second. So how many have coconut but no chocolate? Well, there's only 1 with coconut and no chocolate. So that's that one right over there. And that represents this area that I'm shading in white. So how many total coconut are there? Well, 1 plus 3, or 4. And you see that. 1, 2, 3, 4. And then the last thing we'd want to fill in, because notice 6 plus 3 plus 1 only adds up to 10. What about the other 2? Well, the other 2 are neither chocolate nor coconut. Actually, let me color this. So that's 1, 2. These are neither chocolate nor coconut. And I could write these 2 right over here. These are neither chocolate nor coconut. So that's one way to represent the information of how many chocolates, how many coconuts, and how many chocolate and coconuts, and how many neither. But there's other ways that we could do it. Another way to do it would be with a two-way table. A two-way table. And on one axis, say the vertical axis, we could say, let me write this. So has chocolate. I'll write chalk for short. And then I'll write no chocolate. No chocolate, chalk for short. And then over here, I could write coconut. No, I want to do that in white. I got new tools, and sometimes the color changing isn't so easy. So this is coconut, and then over here I'll write no coconut. No coconut. No coconut. And then let me make a little table. Make it clear what I'm doing here. So a line there, and a line there, and why not a line over here as well? And then I can just fill in the different things. So how many have this cell right over this square? This is going to represent the number that has coconut and chocolate. Coconut and chocolate. Well, we already looked into that. That's 1, 2, 3. That's these 3 right over here. So that's those 3 right over there. This one right over here it has chocolate, but it doesn't have coconut. Well, that's this 6 right over here. It has chocolate, but it doesn't have coconut. So let me write, this is that 6 right over there. And then it has, this box would be, it has coconut, but no chocolate. Well, how many is that? Well, coconut, no chocolate, that's that one there. And then this one is going to be no coconut and no chocolate. And we know what that's going to be. No coconut and no chocolate is going to be 2. And if we wanted to, we could even throw in totals over here. We could write, actually, let me just do that just for fun. I could write total. I could write total. And if I total it vertically, so 3 plus 1, this is 4, 6 plus 2 is 8. So this 4 is the total number that have coconut, both that has chocolate and doesn't have chocolate, and that's the 3 plus 1. This 8 is a total that does not have, coconut, right? No coconuts, the total of no coconut, and that of course is going to be the 6 plus this 2. And we could total horizontally. 3 plus 6 is 9, 1 plus 2 is 3. What's this 9? That's a total amount of chocolate, 6 plus 3. What's this 3? This is a total amount no chocolate. That's this 1 plus 2. Anyway, hopefully you found that interesting. This is just different ways of representing the same information.
Now, a probability is the chance that something will happen or how likely it is to occur. We're going to talk about different kinds of probabilities here, such as basic, not, and, or, and conditional probability. For each one, we'll start with a specific example, then back up and talk about the details of how to do that kind of probability, and finally end with one last example that you'll try on your own. So let's start with basic probability. Here, what is the probability of choosing a chocolate candy? Let's go back up to our Venn diagram and to a table to help us figure that out. Now, every probability starts off as a ratio or a fraction. In this case, we're going to look at the number of chocolate candies over the total number of candies. So look at the Venn diagram first. Within the chocolate circle, we can tell that there are 6 plus 3, or 9 chocolate candies, out of a total 6 plus 3 plus 1 plus 2, that's 12 candies total. So that's 9 out of 12. We could also use the two-way table. How many chocolate candies are there? Well, it tells us here there's a total of 9 chocolate candies. Again, that is 3 plus 6. Out of a total of 12 chocolate candies. So either way, using the Venn diagram or the two-way table, it seems like there's a 9 out of 12 chance of picking a chocolate candy. Let's write that fraction down below. So we found the probability of choosing a chocolate candy was 9 out of 12. Now we often like to reduce our fractions to simplest form. So 9 out of 12 reduces to 3 out of 4. Now sometimes we'll want to write our probabilities as decimals. Now a probability as a decimal is always between 0 and 1. To get there, all you need to do is divide the numerator by the denominator, either by hand or in calculator. Now 3 divided by 4 gives us 0.75. So the probability of choosing a chocolate candy is 0.75. Now sometimes people like to see those as percents. To get from a decimal to a percent, all you need to do is multiply it by 100. So there's a 75% chance of choosing a chocolate candy. So let's review those 3 ways of expressing the chances of getting a chocolate candy. First, we used a fraction, where we put the specific number of outcomes in the numerator and the total number of outcomes in the denominator. Think how many we have out of the total possibilities. In this case, it was 9 out of 12. We also created a probability, which is a decimal between 0 and 1. Remember, to get from a fraction to a probability, all you need to do is divide, either by hand or using a calculator. Lastly, we created a percent. A percent are the chances something will happen with 100% as a maximum certainty. To get from a probability to a percent, all you need to do is take that probability and multiply by 100. Now, there's a lot of information here, and if you feel like I'm going too fast or you can't write things down, feel free to pause, slow down, rewind, and rewatch things as you need. Now, there's one last thing to know about basic probability, and that's how it is notated. Now, we could keep writing things like, what is the probability of choosing a chocolate candy over and over, but in math, we like to be precise and shorten things. So, there's a special way that we write down probability. Let's say something happened called A. Instead of writing the probability of A happening, we could write it like this: P parentheses A, just like that. That means the probability of A. So if I wanted to go back to our previous example, what was the probability of choosing a chocolate candy, I could have written P of chocolate, close parentheses, and that is the shorter way of writing the probability of choosing a chocolate candy. Now, if I wanted to represent the probability of A happening on a Venn diagram, remember that's everything inside the A circle. If I want to represent it on a two-way table, that's everything in that same row or column as A. Now pause here and try and find the probability of choosing a coconut candy. Please find the probability as a fraction, a probability decimal, and a percent, all three ways. Pause the video now. Next, let's talk about not probability, or the probability that an event does not occur. Just like last time, let's start with an example. What is the probability of choosing a not chocolate candy? To figure this out, the Venn diagram and two-way table will be able to help us. Now to figure out which candies are not chocolate on a Venn diagram, look at the chocolate circle and choose everything outside of it. That will include the one candy that was coconut but not chocolate, and the two candies that were neither coconut nor chocolate. On a two-way table, just identify the row that is chocolate, and then take a look at the rows that are not chocolate, all the other ones, which happens to be these three candies right here in total. So either way, there are three candies that are not chocolate out of a total of 12 candies, whether you look at the Venn diagram or at the two-way table. 3 out of 12. So the probability of choosing a not chocolate candy, we said that's going to be 3 out of 12, which as a fraction is equivalent to 1/4, or as a decimal, we can divide and get 0.25, and as a percent, that's 25. So there's a 25% chance of choosing a not chocolate candy out of all of those candies. Now, what about the details of not probability? Turns out that not probability, or the probability that something doesn't happen, is also called the complement. Now, just like before, we've got a shorter way of writing the probability of not something happening. So the probability of not A is written P in parentheses A with little c up here as a superscript, almost looking like an exponent. That C stands for complement. So what would that look like visually? Well, this is something we've already done. If I wanted to shade the complement of A or not A, remember, that's everything outside of the A circle on a Venn diagram. That's including everything in any other circle and everything outside of both circles. On a two-way table, I look for the rows that are not A, and I'll highlight those. Now there's one other thing about not probability or complements that you may have noticed. The probability of choosing a not chocolate candy was 25%. Remember from the first example, the probability of choosing a chocolate candy was 75%. If we add those together, we would get 100%. And that always happens. The probability of a certain event occurring plus the probability of that event not occurring, or the complement, is always 1 as a decimal, or 100%. So instead of trying to figure out the probability of choosing not chocolate candy by looking at the Venn diagram and two-way table, I could have just gone back to the previous example, taken the 75% probability of choosing a chocolate candy, and subtracting that from 100% to get that the probability of choosing a chocolate candy complement is 25%. So let's take a second to answer this last question. What is the probability of choosing a not coconut candy? Remember, your answer should start with the probability of coconut, with this little C up here for complement. Then write the fraction, the decimal, and the percent that gives the probability of choosing a not coconut candy. Remember, you could do this by either using the Venn diagram and two-way table from before, or by taking your answer to the previous set of examples, what is the probability of choosing a coconut candy, and subtracting it from 1.